Hello everyone, welcome to AI Crack channel. This is Akash Gangwar and I'll be your mentor for PGDBA 2023 series. So actually I planned this particular series for last year, but I couldn't do it because of time constraints. So this time I've got enough time to record this entire series. So before talking about this particular series, I'll talk about Prep Master course because that is associated with all these lectures. So basically you'll get certain notes, examples and quizzes associated with this particular lecture. So I have prepared one schedule for these lectures and similar kind of schedule for the lectures, for the notes, examples and quizzes. So if one is looking for starting from scratch, then this particular course is suitable for them. Last year there was one course called Quiz Master. That course was suitable for people who actually have prepared already and they just want to practice random questions. So contrary to that, this particular course will have structured way of presenting things. But in case of Prep Master, in case of Quiz Master, you'll get random questions. So basically the exam kind of format. This one is preparatory, that one is for practice. So this is the main difference between Prep Master and Quiz Master. Schedule will be more or less similar, but the difficulty of questions, the randomness and the structure of the entire lecture and questions will be different. So let's directly start with the set theory lecture number 1. Oh, before starting with this lecture, I'll introduce one more thing, that is question of the day. That thing is basically inspired from Geeks for Geeks. So they have a concept of problem of the day. So I've tried to do similar kind of stuff for AI Crack as well. So basically we'll get one question for every single day and we'll solve it and we can check the solution the next day. So the question will be floated in the lecture series and WhatsApp groups, mails, Telegram groups, etc. And you can just solve it and you can have a look at the solution the next day. Now let's get started with the lecture number 1. So first, let's try to understand what kind of questions do we get in PGDBA related to sets. So there are 3 categories of questions. The first one is related to subsets. The second one is related to Venn diagrams. And third one is related to laws of sets, basically algebra of sets. Now these two topics are more or less similar. Things we can solve with laws of sets can also be solved with the help of Venn diagrams. And but we'll try to cover both the things. I'm talking about this particular thing because we should understand what kind of questions we are going to get in PGDBA. So we'll touch upon other things as well, but we'll primarily focus on these concepts. So this is question number 1 of the question of the day series, and maybe you can just pause the video or you can just take a screenshot, whatever, and solve it. The solution will be provided next day. So let's get started with the sets. So let's start with the definition. A set is a collection of well-defined objects which are distinct from each other. This thing is of primary importance. What is well-defined objects? So basically, when we are defining one particular set, what we are doing is we are associating one single common property or maybe multiple properties with each of the element. So basically, let's say this is A, this is B, this is C, this is D, etc. So every single element should be well defined within a particular property or constraint. So that is how sets is being defined. For example, a set of students preparing for PGDBA. So the common properties, they all are preparing for PGDBA. You can have multiple examples like that. Now talking about representation of sets. So the first form is roster form. In this method, a set is represented by listing all its elements in curly braces and separating them by separating them by commas. While writing the set in roster form, an element is not repeated. The order, however, doesn't matter. So basically what they're talking is this is 1, 2, 3, 5, 7, etc. So this is a set of prime numbers, first 5 prime numbers. So there is one single property associated with it. It is written under braces separated by commas. Now the interesting thing about roster form is it is applicable, it is primarily used for those sets which are finite as well as like humanly countable. So it's not like they're using these sets for those sets which have lakh number of elements or maybe thousands. which is not humanly possible to write. So for these kind of things like very small number of elements and finite, so basically we use the roster form. Now coming to the set builder form, in contrast with the roster form, this particular form has been created. So basically if you have to write a particular set which has, let's say, 1000 number of elements, so you cannot write in roster form, but you can write in set builder form. How can we write? This is the particular format in which we can write. So basically this is the set, this is the variable or element representing variable, and this is the well-defined thing. Like we talked about well-defined property, well-defined object. So this is the thing, this is the property, common property associated with all the variables, all the elements. So let's talk about one example. Let's say we are talking about set x represented by variable x, and it has a property that x belongs to, let's say, 1 to 10. So this is the property. So the set will have 1, 2, 3, 4, 10. This is a very crude example for set builder form. Let's look at the simple illustration for the same. The set of integers strictly between 2 and 8 is represented by. So basically, let's say we're talking about set A and 3, 4, 5, 6, and 7. We haven't included 2 and 8 in the set because it has been mentioned in the question between 2 and 8. So unless specifically mentioned that both of these elements are being included, we have to assume that they are not included. Now, when we talk about set builder form, we have to look for a common property. In case of roster form, we can just write it. But in case of set builder form, we have to look for a common property satisfying all the elements. So here we can clearly see that this is nothing but 25 plus 1. This is 16 plus 1. This is 9 plus 1. So I can see the pattern that this is nothing but square plus 1. So how can we represent in set builder form is, this is the set, let's say this is the variable, and how about the property? The first property is x belongs to 1 to 5. Oh, this is x square plus 1, sorry. X belongs to 1 to 5. This is the property. And x belongs to integers. So this is the property. Now coming to the types of sets. The first one is null set. As the name suggests, this particular set, null set, is having no element in it, and it's termed as null set. So it is being represented by this empty curly braces or phi. Sorry. Yeah. Now let me ask you one question. Is this a null set or not? So I won't be telling the answer for the same. Just write down in the comment section. Singleton set. A set consisting of single element is called as singleton set. So that is very simple. So any set, let's say this is having one element, two, or anything which has just one element is called a singleton set. Finite set. So a set having countable number of elements is called finite set. So the countable doesn't mean that the set having, let's say, 1 lakh elements is not, it's not countable. It's still countable. 1 lakh is countable. It's humanly countable. Although it will take a lot of time to count, but still countable. But when I'm talking about, let's say, a particular set where the property says x belongs to natural numbers, in that case, I can surely say that this particular set is not countable. It's infinite set. So the next one is that only infinite. A set having infinite number of elements is an infinite set. Equal sets, as the name suggests, both the sets should be equal. Basically, if A is 1, 2, 3, 4, so B should be also 1, 2, 3, 4. The order can be different. It can be either, it might be 4, 3, 2, 1. But the thing is, the number of elements and the size of the set should be same. So in that case, both A and B should be equal. Now talking about equivalent sets, in this case, the number of elements in both the sets should be same. So basically, if A equals to, let's say, 1, 2, 3, 4, and B equals to A, B, C, and D. So these are equivalent sets because both of these sets have 4 elements. Subset and superset. Let A and B two sets. If every element of A is also an element of B, then A is called the subset of B and B is called superset of A. So basically we have, let's say, A as 1, 2, 3, 4, 5, 6, and we have B as, let's say, 2, 3, 5. So we can see that every element of B is present in A. If there was a case where this particular element was also present, in that case we can see that 7 is not present in A, so we can say that B is not a subset of A. But in the regular case, like 2, 3 and 5, all these three elements are present in A, so that's why we can say that B is a subset of A and A is a superset of B. So the way to represent this is B is a subset of A. We'll talk about the proper and improper subsets afterwards, but sometimes we will use this or sometimes we'll use this. So I'll talk about when to use this and when to use this. Okay, in case of superset, we'll use exactly the opposite. A is a superset of B. But in practice, most probably we use this. We don't use this in practice, but just for the information. Now talking about the proper subset. Now in the previous example, what we saw that the number of elements in B is lesser than A. So basically if B is a subset of A and the number of elements in B are lesser than A, in that case it's called a proper subset. So basically it can B can be 1, 2, 3, 4, 5. 6 is not there in B. That is a proper subset. But in case B and A are both same, so by definition it's still a subset, right? Because 1, 2, 3, 4, 5, 6 are present in the B as well, in the B set as well. So in that case B is still a subset, but it's not a proper subset, it's an improper subset. So that is the difference for proper and improper. Now when we talk about uh, improper set being inclusive, in that case we'll use this sign. But in case we just want the proper set, in that case we will use this sign. So basically when this is mentioned that, so basically when this is being mentioned, we can assume that there can be one case where B and A both are equal. But in this case, B can never be equal to A. Now let's look at one illustration. Let A equals to this. Which of the following statements are correct? So let's rewrite A as 1, 2. Let's call this small a and 5. Now let's look at option number A. Here it is written that A is a subset of A, which is not true. If this was written in this manner, in that case we could have said that okay, this is a subset of A, so A is not correct. Now let's talk about B. B says A belongs to A. This is true. Whenever we write an element, like if we talk about 2 belongs to A, yes. A belongs to A, yes. 5 belongs to A, yes. So that's why B is true. Now talking about C. So sorry, one bracket is missing from here. So now this is similar to this one. So basically this is a subset of A. That is true. So C option is also true. Now talking about D option, 1, 2, 3 is a subset of A. This is not true because 3 is not a part of set A. 3 and 4 in a set is a part of set A. So that is why this is not true. Now let's talk about number of subsets. The total number of subsets of a finite set containing n elements is 2 raised to power n. Now we know the formula, but how do we get this formula? So to understand that, what we'll do is, let's say we have a set A called 1, 2, 3, 4 and 5. Now we want to create one subset B. Now this subset B will have maximum number of 5 elements. So we are talking about all sorts of subsets, not just improper or proper. We're talking about all sorts of subsets. So it can have maximum 5 elements, right? Now every element can be either filled or not. So by these elements. So let's say if we are talking about one, so one can either fill it or not. So it has two possibilities. Similarly, here two possibilities, two possibilities, two possibilities, possibilities. So let's take just one case. Let's say one is being included, two is not being included, so it's empty. Three is included, four is included, five is not included. So the subset is 1, comma 3, comma 4. That is a subset. So basically, I can see that with these possibilities, we can make all sorts of subsets. We can have the improper subset as well. We can have the null set as well. When none of these elements are being included, in that case, we'll get a null set. In case all these elements are being included, we'll get a improper subset, right? So that is why by simple law of multiplication, we can see that 2 raised power 5 are the possibilities. So that is why 2 raised power n, right? Now, if we're talking about total number of proper subsets of a finite set, then definitely we'll have to subtract 1, that is the equal set. So basically there will be one set B, which will again be equal to 1, 2, 3, 4, and 5. In that case, we have to subtract this one. So that is why 2 raised power n minus 1. Oh, I think this is the wrong slide. Yeah. Now talking about the power set. So power set is nothing but it is the set of all subsets. So let's take this example. We have the set A comma B. So basically 2 raised power 2 subsets will be there as we discussed earlier. So these subsets are null set A, A and B both singleton sets, and A comma B equal set, which is basically improper set. So a set containing all these elements is a power set. As mentioned here, power set is like this. So basically a set containing all the subsets of set A. Now let's look at one illustration. Find the number of subsets of power set of 1, 2, 3. Now we have got this set as 1, 2, 3. So number of elements in subset of A, not A. So basically number of elements in power set of A, right? That will be 2 raised power 3. So basically 8 elements in power set. Now we have to find the subsets of the power set, right? So in that case, 2 raised power 8 will be the number of subsets of power set. So 256 is our correct answer. Talking about the universal set. Now, universal set is being defined in a manner that it contains all the possibilities related to a particular problem or situation, all the possible elements. So let's say we have A and B and C. We have these three elements with some n number of elements. In that case, if universal set is not being defined, so we'll take union of these. We'll take all the elements. I won't talk about union now. So basically, what you can understand is we'll take all the elements from these three sets and make a set called universal set, which contains all the elements. So that is called a universal set if it is not given. But if it's being mentioned, then we have to use that one, right? Talking about Venn diagrams, sometimes what happens is it's highly difficult to visualize the situation, the entire set theory situation, via just equations. So Venn diagram are used for such cases. So let's look at one example. Now we have these sets 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what is happening here is we have got a universal set which has elements from 1 to 9. Now this particular set A, this is set B. So this particular set A is having 5, 6, and 9. This particular set B is having 9, 7, and 8. But to conform with the laws of sets, like elements shouldn't be repeated. In that case, we are representing these circles in such a manner that this particular element is being written only once, not twice. Both A and B are having, but in this particular set, we are just writing it down only once. So that is one example, one standard example of Venn diagram to visualize things, what exactly is happening. So basically this is called intersection. We'll talk about it later, but this is how it's being represented. I think all of you all already know about it. Just give an example. So this particular lecture was till here only. If you do like the lecture and the videos, do share this particular channel or this lecture series with your friends so that they can also benefit from the ongoing mathematics series for PGDBA. And if you want to practice more, definitely you can just subscribe to the Prep Master course. You'll get ample number of questions related to these lectures only. So let's meet in the next lecture. Thanks for watching.